Yalla. Good morning and welcome back again to the class. Today we are going to the new chapter, chapter 10. In this chapter, we are mentioning some important things with a sequence. And if you need to write some reports about the application, actually in the chapter 10 and 11 has got many applications. So for here, we have a sequence. In chapter 10, generally speaking, if we have chapter 10, one of them is sequence, totally different. And the rest, we have 10.1, 10.2, till 10 point something else, I don't know, 8, 9, we have series. Sorry. Here's the symbol is like that, here's the symbol is like that. Okay, here we call AN, and from, for example, 1 to infinite, like that. So the symbol of them is different. Here, in the 10.1, we are depending on the limits, especially when n approaches to infinity. We have just like that. But here, no. Here we have techniques plus limits. So you need the limit 100% here. So I'm going to 10.1. Here we are. In chapter 10, we have a sequence as we say that. Let me go to the lecture and you can see. We have such order, such arrangements, such terms like that. A1, A2, A till AN. This means that the sequence. For example, if I say 1, 2, 3, and go on till infinity, we can summarize, we can symbolize that one, make it as summary. We say AN is equal to n from 1 to infinite. Means that the first term is what? AN. First term when n is 1. So we have n1. The second term, we are going to increase the number by n. N is a natural number. N is from natural number, and natural number is what? 1, 2, 3, and go on. So at the beginning, I put n1, 1, the second 2, 3, and go on. Understood? When I say Bn is equal to n square, of course, n from 1. So when we show us a set, we have what? Yalla. The terms, tell me about the term. 1 square, right? So 1. 2 square is equal to 4. 9. Understood? So this is how to deal with it. When I say Cn equal to n over n plus 1. Now we have what? Cn equal to what? 1 over 2, 2 over 3, right? Substitute n. N is 1. So 1 over 2. Next step, n is 2. So 2 over 2 plus 1, 3, and go on. Like that. Understood? For example, if I have Dn, sometimes you don't write anything here. When you don't write anything, means that from 1 to infinite again. So how about that one? Dn is equal to what? Yalla. Minus 1, okay. 1. Understood. How about if I put that one, if I change that one to now 1, 1 minus 1, 1 minus 1, and go on. How? We put n from 1 to infinite, we substitute n to here. So when n is 1, I will get minus 1 to power 1 plus 1. With minus 1 to power 2 is equal to 1. That's how. So just substitute, it's easy, right? Good. So now we have some situation like that, some example like that. And the sequence is finite. It's finite, for example, I say n square, n from 1 to 10. N from 1 to 10. How we represent that one? We say is equal to 1, 4, 9 till 100, right? So this is the finite sequence. Why finite? Because we have, for example, million term, 10 terms, million terms, 2 terms, okay? This is finite. When we say n approach and go, so or something like that, so you know that one is infinite term. That's all we need to know about. Do you have any question? Put your mobile away. Do you have any question? Good. So now look at here. Look at this example. An is what? Is equal to square root of n. So if we add, I'll get 1, square root of 2, square root of 3, and go on. Understood? Now look at Bn here. Bn is minus 1 and 1 over n. If n is 1, I will get what? Only 1. If n is 2, that one will be 2 plus 1, which is equal to 3, which give me minus 1, right? And this will be 2. So that's why I got minus 1 over 2. When n is 3, again substitute here. N is 3, you can substitute. And you get what? 3 plus 1. Here also will be 3. So I'll get 1 over 3 positive and go on. Understood? How about Cn? 0 over 1, right? Am I right? 0 over 1. So I'll get 0. First term will be 0. The second term, change n to 2. So I'll get what? 2 over, right? 1 over 2 and go on. Understood? Easy to substitute, to learn about the first time. And how about that one? We solve them. Maybe plus, maybe minus, does not make a sense. The important thing, just substitute to get the formula to understand what's going on. Okay? Do you have any question? So which one of these A and B and C and D and is finite or infinite? All of them are infinite terms, right? So good. Okay, let me see what's going on. And here's the picture. Here's the picture. The sequence, like a AN, is the graph, is the function from natural number to real number. Means that I am putting, I'm an input, I'm an output, that one. We are inputting natural number, n1, 2, 3, 4, 2 here. This is all natural numbers. So our input that I'm giving to the machine is natural number. But the result is something else. The result sometimes is square root of 2, right? Which is real number. Maybe 1 over 2 is rational number. So all this one is like a definition for this. Because it's a function, of course, the function has got graph, right? We are not depending on the graph and domain range here, just for your information that this is the graph of first AN, 1, square root of 1 is 1, square root of 2, 3, 4, and the result will be what? When we have 1, I'll get 1. When I have 2, I have square root of 2. When I have 3, I have square root of 3. When I have 4, I will get 2. Understood? So that point, if I mention that when I see is a 4 over x axis, 2 over y axis, am I right? If I am going to mention that yellow one, the yellow point, I see this one is 2 square root of 2. You got it. And the same thing is true for the rest. CADN and that. During the exam, I'm just asking you, show me the following sequence. Are converge or diverge? So you'll use the limit and you'll give me this after some steps, then you'll answer. Understood how? For example, let me just give you clue about how to deal with that one. We have AN or anything, AN or any name is equal to 1 over N. I see that one is converge or diverge. And with the detail. How we deal with that, how we answer that one. The answer is depends on the how you see the or the direction that you are thinking about the question. How? First of all, I'm going to put what? Put the numbers, so 2 numbers. So I'll get 1, 1 over 2, 1 over 3, 1 over 4, and go 1 over N and go till infinity. Am I right? So show me if we are in 1. Think about it. I am in 1. Next step, I am where? 1 over 2. Am I right? How about after that one? If this is 0, 1 over 3, 1 over 4. Am I right? 1 over 9. Am I right? So I'm going to where? I'm going to where? 2? Yeah. So here we are. This is 1. The graph is 0. At 1, I'm in 1 over 1. At 2, going to 1 over 2. At 100, at 100, we are in 1 over 100. At million, we are 1 over million. It's going to where? It's decreasing, right? From y-axis. Look at here. From y-axis, the number is decreasing. To where? To touch that line. That line is what? Y equal to 0. Am I right? So, from 1 we decrease to half, quarter, 1 over million, 1 over, I don't know, very, very close. We are going to what? That red one over y-axis is going to be or decreasing to 0. That's why I say the limit, look, the limit 1 AN, we are going to take a limit. I say the limit n approach to infinite for AN is equal to n approach to infinite 1 over n. Am I right? Was going to be what? 1 over n. Yesterday we talked about that one in 8.8. We have 3 cases. Do you remember that? Upper greater than lower, lower greater than upper, they are equal. So it's equal to 0. Understood? So because the limit of AN is number, is result, we see is what? Is converge. Understood, Jamaat? Clear? Okay. Still, we are in the introduction. I'm not going to the subject. So we have 2 things. What's the difference between that and that? Right? From chapter 2, chapter 8, everywhere in the Thomas calculus, when they talk about it, something, we have X. But here you can see in your lecture, we're talking about N. N. Why? What's different between that one and that one? Yes.
X could be anything. So 2, 5 over 4, but N is a natural number.
Good.
So that's why in sequence we use natural numbers. But in X, as I said, it could be anything. So that's
okay.
Also the graph is also.
Okay, I got it. Thank you. Any other comments? Any other idea? What's the difference between them? She's right totally. Any other comment extra? Yeah.
I think n is by sequence, but x no,
So
we can put any number.
any number. So here's, for example, if I am between 0 and 1, here if I am between 0 and 1, okay? When we are working on here, here's x is a real number. So the steps are like that. Steps 0.0, 0.001, 0.001, and go till 0.999. Understood? So how many steps here? How many steps between 0 and 1? Infinite, unlimited, infinite, yes. But here, it's like a gap, one step. Understood? So that one will make the function or the expression that we have to be zero, to grow or to step is very fast. But it's not occur, it's not a perfect. But that one is slow, but it's perfect. You know, for example, if we are writing the program, if you click on that one, maybe you need 1 hour, for example, to understand. But if you click that one, maybe you'll get by 1 second. But that one, the result of that one is very accurate, more accurate, exactly. But that one is approximate. Sometimes you have an error. For some simple example, yes, is good. But for the complicated example, is not good. Understood? So that's the difference between, as she say, maybe everything x, maybe pi, I don't know, is going to anything. But that one knows 1, 2, 3, like a jump. 1, 2, 3, no more else. There is nothing between them. Understood? Good. So for example, between 0 to 2 times infinity, we need the steps. Here, from 0 to 2, just we need 2 steps, no more, nothing else. So that's the difference between them. Thank you very much. You got the points? Maybe you say, but as a rule, rules, law, properties, rules, whatever you say, both of them, they are the same, totally. For you especially, they are the same. So does not make a sense, does not make a change. Everything is good here. Now we have a converge. Look, how about here? How about that example is going to be converge or diverge? That one, if I took a limit of here, I'll get what? Limit of 1 minus limit of 1 over 0, infinity, 0, right? So the result will be what? For example, if Bn is Bn equal to 1 minus 1 over n, Bn will be 0, 1 over 2, 2 over 3, and go on. So about testing, about to clarify, answer the Bn is converge or diverge, I don't know. I say let n approach to infinity for Bn, which is equal to limit n approach to infinity for 1 minus n. And I know that one will be 1 minus limit 1 over n. And I know that one will be 1. So because I got the result, it's converge. Understood, dear? Okay, tell me about the third one. Yalla. Cn equal to square root of n. So limit of Cn, n approach to infinity of Cn equal to what? Infinity, exactly, and it will be diverge. How about the last one, Dn? I get what? If I took a limit for Dn, the answer will be what? Yes? One and negative one. So we got 1 or negative 1. So in that case, what's going on? Yalla. If you have 2 values, does not exist. Does not exist. Why? Because the limit, the result of the limit should be unique. the output, yes, or the same. If you have a right, left, they should be the same. So for it does not because is oscillate. Okay, oscillate means that, you know, 1 minus 1, or I don't know, 0, 1, 0, any numbers. And the important thing is we don't have unique. For example, here the value should be one number, unique number. Understood? So because we have two numbers, I'm approach to where? To the door, right? But you cannot say I'm approach to the door and to the window. There is no something like that. We cannot separate. So that's why the limit is like that, one direction. Understood what I mean? One result. You are approach to where? It's okay, you say I'm close to the door from right side and left side, but there's a door. But there's no two subjects, door and window. You know what I mean? So that's why we say it does not exist. So if does not exist means that we don't have a result, right? And means what? Diverge. You got it? So how many types of diverge do we have during here? We got infinite or minus infinite maybe, and maybe does not exist also. So we are going to use that one. Actually in 10.56, we need this again and again, these ideas. So careful, and here we are. Because bounce back forth between 1 and minus 1 converts to single value. The value should never converge to single value. Means that single value means that unique value, right? So is not oscillating and it does not exist. Now, and we have a definition of the convergence. You don't need here, but to learn about that, you know about that. If we have a result, this is by showing the limit by definition. It's not included for you, so okay. And the important things, we should have a result. We should have a result. Where's divergence? When you have infinite or minus infinite or does not exist. That's all about limit. Do you have any question as an introduction to the limit, to the sequence? Did we mention anything else without limit? No. Our tool, it was what? That we are going to use just limit. So kindly try to review limit unit, especially limit for what? In this chapter 10, we need limit to infinite. So go use all idea about L'Hopital's, I don't know, conjugate, sandwich theorem, polynomial over polynomial, many things, I don't know. Whatever we mentioned, we need it here. So again, we have limit. Look, limit of a limit is very flexible. It's not like an integral. You can distribute it over addition. You can distribute it over subtraction. You can bring it out the scalar numbers and then take the limit of the function. Also, there's a flexibility about division and multiplication. So you can distribute. So just use the limit. Okay. So for example, if we have integral with a sine cosine, yeah, x e to power x, that's something like that. We couldn't say x dx e to power x dx, right? We see that one as kifr. You remember. But for the limit, yes, you can do it. You can say is equal to x e to power x. For that one, yes. For that one, no. And unfortunately, you use or you are doing for that one, but you didn't do it for that one. So we need that one as everything is clear here. We don't need the things. And there's the application of the rules. Look at here. So tell me about the first one is equal to what? It's easy. Yalla. Equal to what? 1 over infinite 0. So you get the 0 converge. How about that one? How we solve that one? Second one, day. Quick, you know. Equal to what? L'Hopital. What else? Infinity. Well done. What else? Indeterminate form. What else? We can separate them. Yes, polynomial over polynomial. Degree 1. So we have three cases equal to coefficient, right? Easiest way. You can also solve by L'Hopital, but you don't need to. We see that we have polynomial, for example, right? Every x changes to the n, nothing else. So n plus 1 over n to power 3, 5, n squared plus 2. So the limit of here, of the sequence, is equal to what? 2 over 3. So it's equal to 0. Why? Because denominator is greater. We say that. We have three cases. How about if this one, 2, we say is equal to 1. How about if that one is 1? Infinity, right? We have three cases. So apply three cases here without hesitating. So you get the 1. N squared, 2. How about that one? Yalla. D. Quick. 0. Well done. Why 0? D. C is equal to 0. Come on. 7. No. Minus 7 over 1, right? Was equal to minus. You got it. Why? Because 6. So coefficient over coefficient. Understood? That's why I say review it. Is there anything else? It's clear, right? We mentioned everything before. So it's clear. Good. So here we are. Now, tell me about sine n over n. First, let me substitute directly. We have cosine of n. This is the angle. Do not forget, with the cosine you have angle over n. So let be that one, we call that one an. During the exam, I say, show me that one is converged or diverged. So how we test, how we show, we say limit of n approach to infinity for an is equal to limit of so denominator for me, discount 50%. So tell me about numerator. Zero. How do you know 0? Cosine 1. How do you know it's 1? Cosine 1 is 0. So, but I have infinite here. So cosine is like that, right? Oscillating. So cosine is going to where when it's infinity? We don't know. From here to here to there to there and go on, right? My x, my n, here's n. My n is going to infinite over that axis. So sometimes from the beginning, you are right, 1. But later it's going to be to 0, -1, -half, right? Half, quarter, I don't know, many numbers. So how many numbers do you have between here? On the y-axis, infinite, right? So it's going to what? To infinite? No, you cannot say it's going to infinite. Because between 1 and 1, -1, 0. So oscillating without anything. So how we solve that one? I remember I solved some example like that, and I gave you the question. We know cosine of n is between what? So are you hungry? Hungry? So we are using what? If you are hungry, sandwich. And we are going to divide by n both sides. I remember I saw something like that in chapter 8. So you need a review. And I am 100%. I know that one is going to be what? And the other bluff of part of the bread is 0. So falafel is going to where? 0. You know why I say falafel, huh? So that one is 1 over n. That one is -1 over n. And here's falafel, right? That one is cosine n over n. So if that one is going to 0, sine it, and that one is going to 0, of course, you ate that one is equal to 0. It means that if you eat that one, of course, there is no falafel remains. Okay. So that's all about the examples. You can see from here. For example, if you like to solve that oscillator, how about 1/2n? You can solve by that method or by the easiest one. 1/2. 1/2n bn. So is equal to 1/2, 1/4, 1/8. Am I right? And I go on. So it's going to where? 0, right? And we say that, I remember, we say that 2 to power n, when n tends to infinity, is going to where? To infinite. And we say that n tends to infinity for 2 to power minus n is going to where? 0. So you can put what? You can substitute that one as a 1/infinite was equal to what? 0. Or you can say that one is equal to 2 to minus n, and again is equal to what? 0. You remember that in E, we say e to power n, or number 2 to power n, all this one. When n approaches to infinity, we will get infinity, right? E to power minus n, or you can say 1/e to power n, 2 to power minus n, 3 to power minus n. All of them, when n approaches to infinity, you will get 0. So you need to review that one again and again. Understood? Okay? Pay attention. Good. So here we are. That's why I am not going to use everything as a book. No, I'm thinking about that one's easier. That one, oh, cosine. Oh. How about the C? Look at the C. We have minus 1 to power n, and we have 1/n. I have a problem. We say we can separate the limit, right? That one will be 0, I know. But that one is what? It's oscillating. Understood? So I cannot answer. When oscillating, I cannot answer. So how we solve the oscillating? I know minus 1 to power n, 100% is between what? Between 1 and minus 1, oscillating, right? Now again, we are going to divide by n as a sandwich, 0, 0. Of course, here will be 0. You got it, dears? Do you have any question? Do you see something new? No, just limit and limit and limit. Okay, if you forget, but here we are going to, what do you say? We are going to review it for you. You can see here. So that one is not included for you, theoretical part. Okay. Do you have any question? Good. Another example, another idea. Each example here has got another idea. P over polynomial was example number 3. Here, sandwich theorem, example number 4. Here, we have continuous function. What do you mean by continuous function? We have a limit of continuous function. So here we have a sequence of the function. The same theorem, you got it in chapter 2. Especially in the, I think it was in the derivative, I don't know, in somewhere else. So look at here. If you have, for example, just for remembering the theorem, if you have x, I'm going to the calculus 1, that's why I mentioned x, going to 0, you have tan of sine of x under the square root. How we solve that one? We have function. The angle again is what? Function. Okay. Even you can write down like that here. Look. So function, angle function, and also another function. 3 functions together, or 2 functions. So how we took that one? How we deal with that one in the calculus 1? We say because tan is continuous function at 0, and sine again is continuous function at 0. Second, and also x plus x is a polynomial which is continuous everywhere. Continuous. So we can deal with that like that. We say is equal to tan sine limit x squared. We bring the limit to inside. By what? By that theorem. We didn't do it arbitrary or just by ourselves. No, we have a rule. We have a theorem here says if the function is continuous, at that point you can do it. So we will replace here 0 plus 0 is equal to 0, right? And sine of 0 is equal to 0 again. And tan of 0 is 0 again. And square root of 0 is 0. That's how we answer. We see the 0. We don't say, no, just put the zeros, okay. No, we think about the functions continuous at that point or not. The values exist or not. So that's how we got this. The same thing is true for here. We have sequence of n, sequence of n plus n over 1. Sequence an is equal to n, n plus 1 over n. So how we answer that one? Look at me. I say for the limit, I will take a infinite for an. I'm not going to repeat. So the limit of here, n plus 1 over n. I don't say that one is coefficient over coefficient. Why? Because they are not polynomial. We are under the square root, but I am sure that that square root function is continuous. That's why I'm going to take the limit to inside. And here we are. And now it's polynomial over polynomial. And it's equal to coefficient, right? Second case. So I say is equal to what? 1. That's why I'm writing the square root to understand what's going on. Then I say is 1 and converge. You got it, dears? So that's the theorem. Tell me such example like that. Yes, 10. Yes, we cannot bring it to inside. We should find such another way, or we say we don't know, or is equal to infinity. Because we are in the asymptote, it's going to minus infinity, I think, right? Okay. Real example starts. Now, len n. Look, you saw that one many times in 8.8. Bn equal len of n. Yalla. First of all, two answers converge or diverge, we need to what? Take a limit. Am I right? Yalla. Limit of that one is equal to what? Limit of len infinite. You remember that graph. Infinite. Limit of n. So how we deal with the infinite over infinite? Euler is a indeterminate form, right? First type. So it's equal to what? 1 over n over 1. And the limit, so it will be 0 over 1. Easy, right? Why easy? Because you saw that one. Because we deal with that one. I change it to the x to remembering you, then you see that one. How about n plus 1 over n minus 1? Yalla. You are happy today, right? Because you postponed many such problem. So how you solve that one? Just limit, right? Take a limit. Okay, limit n approach infinity for n plus 1, n minus 1 over n. Yalla, tell me is equal to what? If I substitute directly. Infinite over infinite. 1 power infinite. Bring it to inside. Good. Bring it to inside. You'll get 1 because polynomial over polynomial. And here it's going to 1. So 1 point infinite is type what? Is indeterminate. Which type? We have a which part? We have 3 parts in the indeterminate. infinite same dana. So same dana is what? And we call that one as what? As power. Power, it was 1 infinite, 0, 0, infinite, 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 0, 0, infinite, right? So which type, Anna? And how we solve that one? Huh? By ln everything, right? So we are going to solve that one step by step. Then later I'll give you such an easy idea. You can deal with it, okay? So now dn is equal to n plus 1, n minus 1, n. Let me just check n plus 1 over, yeah. So we say ln of dn, am I right? Is equal to ln of n plus 1, n minus 1, n. Yes, comment? You know why we are going to use ln? Because we have a power determinant, indeterminate, sorry. So I know, and that one will be n over, sorry, n ln plus 1, n minus 1, right? And now I'm going to take a limit or substitute the limit. I'll get what? Here it was infinite over, sorry, 1 over infinite. How about here? Yalla. Hey, just substitute infinite. That one will be infinite. How about that one? 1. Close. No. You don't think about that one. Forget about any rules. Just put infinite here. You'll get what? Minus 1. Yes? You know, yalla. I'm going to take a limit for here, right? Right? Understood? Okay. And I see is equal to 2 parts separate. That one will be infinite. And the limit of here, am I right? And we say that in the previous example, limit can come to inside. Why? Because it's continuous. Ln is continuous in the positive part. Am I right? Have you seen the gap in the Linus graph? No, we have there's no gap, so it's continuous. So it's going to be am I right? Now it's polynomial. I'll get what? Yeah, it's equal to what? 1. And ln of 1, 0. Now you got that. We change that one to, we say that before, you remember. Then we are going to change that one to some of them, one of them. Understood? So how we change? We did like that before. How we change? There was sign example. No. How we change that one? N ln of n plus 1, n minus 1, which on this type. How we change it to that type? Or one over n, we bring it to down. We say is equal to ln n plus 1 n minus 1 over n. We have an example on sine. You remember? Sine over sine 1 over x. We change it to like that. Understood? Now you know why we bring that one. So which type that one? Let me check. Ln of 1, 0. Ln, here's limit is going to infinity. 1 over infinity, 0. Now we change to 0, 0. From here, we bring it to here, or often here. Then we change it to that case. If you review it, you will get all idea together. Any new, which does it? No, everything mentioned. But we apply here. We apply like a review of calculus 1. And instead of x, we change it to n. Nothing changed. So Okay. Now I'm going to repeat it for you. We have dn, which is equal to n plus 1, n minus 1 over n, and that one will be over that type. So I'm going to use ln of dn. It will be ln of here, and will give me n ln of n plus 1, n minus 1, with the type of infinite multiply 0. Then we are going to change that one, ln of n plus 1, n minus 1 over 1n with type of 0 over 0. Now it's time to what? To take what? LD whole capital, right? Derivative of numerator, derivative of denominator. Yalla. Derivative of denominator for me, discount. Okay, for me. Is equal to what? Am I right? Right? Okay. How about denominator or numerator's derivative? Huh? By quotient. Thank you. So it's equal to what? Before that one, tell me about ln of u, derivative of ln of u is equal to what? 1 over u. No, you are right, not right. U prime, right? So how about derivative of 1 over u is equal to what? U 1 over u, huh? Like that? Well, why? Shall I repeat it? A little bit, I need your concentration here, right? Actually, 1 over u, so we say 1 over u, and 1 over u prime. So 1 over u will be u. 1 over u prime is equal to minus 1 over u square. Am I right? Now I'm going to change this example to get the idea. Is what? Then over 1 plus, I say y prime 1 over here means that, am I right? 1 over, we reverse it, and prime. Why? Understood? Shall I write in another page, another way? You got it, dears? Good. So derivative of here is equal to what? Quotient rule, right? So it says equal to n minus 1, n plus 1 in its place. So derivative of here is equal to numerator square, numerator, derivative of denominator, sorry, numerator minus denominator, numerator, derivative of denominator. And by default, we get what? In that one, n minus 1, n plus 1, n minus 1 square, okay, n minus 1 minus n minus 1. Am I right? Okay, now it's time to cancel that power with that one. Am I right? Minus n with a plus n. So it remains n minus 1, n plus 1, minus 2. Am I right? Any question? So that's why I'm going to write in here do you have any problem? Understood why? Okay. طيب أنا بنعمل limit for both sides. I'll get ln of dn again, limit to here, n approach to infinity. Understood? Any difficulty? Let's check again. Any problem? Any issue? Any comment? Kindly ask, step by step. We took a limit, ln, we changed to that one, and that one need to L orbitals. So derivative of here, we mentioned in the other side is equal to here. So I'll get what? Look, I'll get what? This one is going to up. So will be minus 2 multiply minus n squared. Am I right? And I know this minus with that minus will be positive. So by the green, that minus with that minus. So I'll get what in here? Just, sorry, just what? 2n squared. And in down, in the denominator of here, I'll get n squared minus 1. And the result of this limit is equal to what? 2. Why 2? You know. So ln of, you are right, the coefficient. Well done. Ln of dn equal to 2. dn equal to what? e to power 2. Converge or diverge? Converge. So here we are. an ln n that form, change it to that form. Derivative of here is equal to that one. The result will be here. We have what? an is equal to e to power n. Understood, dear? Do you have any problem? Okay, now we have 6th rule, okay, which use so many of them, but now we are going to apply them. How? First of all, you should understand how that one is equal to 0. You cannot memorize them actually. For me, I cannot memorize them. Without the 6th one, which need many idea to solve. Otherwise, you can find all of them. How? For example, the first we solve ln over n. We use the L orbital, right? And we say n over n, which is 1 over n, and is equal to 0. So look at the example of first. We have ln square, ln of n. So the first rule, we are going to use these texts in the other sections of chapter 10. So carefully, do not forget about them. The first rule, you say n approach to infinity, ln n over n equal to approach to what? To where? Means that approach to 0, equal to 0. How? Here's the example, ln of n squared over n. So how we solve that? And we say n squared by the ln will be 2 ln n over n, right? And that one is going to 0. So 2 multiply 0 is equal to 0. We say converge. Understood? Now we are going to apply the second example, the second rule. Sorry. Look at the second rule. We have nth root of n equal to 1. How? I don't know. Maybe 0. Maybe in the exam you confuse 0 or 1. I don't know. So we have nth root of n when n approaches to infinity. He say that is equal to 0 to 1. Am I right? So how we know is equal to 0 or 1? Just simply, you can solve it by yourself like that. Am I right? So limit n approach to n. And that one is infinite over 0. Why? So how we solve that one? We say let that one an. An be n. So I say an ln of an is equal to ln of n 1 over n. 1, yeah? How we solve power? By ln, many times. So bring that one to down. You will get what? 1 over n ln of n, right? And we solve that one in the first part. We say ln of n over n equal to what? When n approaches to infinity, we will get 0. So ln of an equal to 0. Take e for both sides. That one will be an, that one will be 1. E to power 0, 1. So nth root of n approach to where? To 1. You got it, dears? This is the second and this is the first. Okay, here's the example. I'm going to solve the example. Look at here, n squared. We have n squared of nth root. This is the sequence. I say how I solve that one. I saw this shape before in the 6th rule. So I'm going to change like that. Sorry, 2. How? Because I know if I have 3x4, I can write this one as x4 over 3. Am I right? Also, you can write that one as 3x4. Also, you can write that as x1 over 3, 4. All of them, this form, the same. So that's why I can write that one, rewrite the example, nth root of n squared as a square, bring the square to here. So, and I know the limit of here is equal to what? 1 by the second rule. So 1 squared is equal to 1, which converge. Again, you can see from here, we have that one, you have that one, you have that one, you have formula 2. The third formula, look how we have x and n here. Why? Because x here mentions a number. Which number? Greater than what? 0. So how I forget about x1 over n is equal to what? I don't know. x1 over n equal to what? I don't know. So again, say an. Ln of an will be 1 over n ln of x. X is any number greater than 0. So I will get what? Limit of both sides. Limit of here equal to ln an. Limit of here equal to 0. And limit of x is number. So still remains ln of x. 0 multiply number, 0. Again, take e for both sides. An is 1. That's why we got 1. You don't need to prove for me how is equal to 1. But if you forget, you can review it by 2 seconds, 3 seconds, all of them, because you know how to deal with that one. So I will get something like that. Look at the example. Look at the examples. That one, 3nn. Look, nth root of 3n. I saw that one before, right? So I'm going to make it like that, because square root can be distributed over multiplication. But for addition, you cannot do anything. So, because you have multiplication, that one is equal to what? By the second formula, right? And how about that one? Is equal to 3 1 over n. And this is the x. 3 is greater than 0. Yes, that's why also this one is going to where? 1 by the third formula. So 1 multiply 1 is equal to what? 1 by 1, formula, and I'll get the result. Fourth formula, we have xn approach to 0. So how we deal with that one? Xn approach to 0, how? Or equal to 0, how? But we have a condition here. So what do you mean by absolute value of x less than 1? What do you mean by that one? No. No, means that x between 1 and minus 1. But exclude minus 1, exclude 1, like that. Understood? Hello? Good. So means that x be what? Fractions. 1 over 2, 1 over 3, 0, and minus 1 over 2, right? Okay, absolutely. Okay, it's less than 1. It's less than 1. Right? Minus 0.99 is less than 1. also 0.9 and her less than 1. That's why we mean the fractions, number fractions here between between 1 and -1. Good. So if I have such number like that, for example, 1/2 to power n, it's going to where? 1/2, 1/4, 1/8, and going to where? 0. That's why you see that if we have a fraction, is going to 0. So how many zeros we have? 2 zeros. How many 1 we have? 1. Okay. So let me write the rules for you again to remember. Ln n over n. Okay. Nth root of n xn to 0, where x between 1 and -1. And what was the third one? 1/n. X, any number, 1/n is going to be 1. Good. Now, the fifth rule, rule number 5. We have ln of 1 plus xn over n. He says is going to be what? Going to be e to power x. How? Yalla. An equal to 1 x over n is equal to 1/infinity. Am I right? Why? Because n approaches to infinity, that one will be 0. That one will be infinity, that one remains 1. So how we deal with that situation? Same. How? Oh, and x, careful. Am I right? Okay. Then now I have infinite. Right? Infinite. How we change infinite multiply by 0? The second situation to the first. How? You see that before. Am I right? Then take derivative for both sides. You get what? I don't know, you get what? Actually, you need many things to do. So you get what? The derivative of here and the derivative of here. So I say n over n plus x, okay, multiply denominator square, numerator, sorry, denominator. You know what I'm going to do? Derivative of ln of x plus n. So denominator multiply numerator is equal to 1 minus numerator multiply derivative of denominator is 1 again. So that one will remove, that one remove. It remains minus x over -1. Something like that. I think there's something wrong. Yeah. Was good, that one. This is multiplication. That's why I say something wrong. So look at me. That square with that square remains. And that bracket will be what? Will be minus. And n with minus n will remove. And that minus with that one remove, it remains nx over n plus x. Am I right? And this is ln of an, which is equal to limit of n approach to infinity for nx over n plus x. And that limit will be what? X is free variable. N is the deal with the limit. So it's equal to a coefficient over coefficient. So x over 1. So it remains x. Am I right? Now time to take E. What do you mean by that? Means that if you have equal to what? Yalla, quick. Without thinking. Equal to what? E to the power F. That's it. How about that one? You got it? Easy. So the first, I prove the rule for you. The second, we do what? Yeah. E to the power. Look at here. N minus 2 over N minus 2 over N nth. Look at that example. So how we solve that one? Change to that one, to that formula. Okay? How? Separate N. Am I right? And you get what? 1 minus 2 over N. Is that formula or not? So E to power minus 2. Thank you. So mean that you are here. Good. So you get E to power minus 2. Do you remember the previous example? Do you remember that? We used 1-2 page with the many derivatives to get that one. Now I am going to change such idea. Use that some idea. Look, N plus 1 minus 1 plus 1. I just add that one, right? Is any problem? No. So I'm going to change. I say equal to, I'm equal. It's equal to N minus 1 plus 2. Am I right? Huh? Okay. Now I'm going to separate. Am I right again? Was equal to what? You got it? Easier. So you can use the formula. Whatever you like. The last one, the last rule, the last formula, sorry. We have x and n factorial. I cannot tell you how to get that one actually. You need many times. N factorial. You know it's a factorial. For example, 2 factorial equal to 2, 1. 3 factorial is equal to 3, 2, 1 is equal to 6. So the limit of that case is going to be 0, I think, right? Xn over n factorial. So x is any number. Look at me, the last one. For example, if I have 10x over n factorial, n approach to infinity, I say is equal to what? 0 without thinking, because actually there's a rule how to solve, but we need to just find it. Any question about this T6 formula? Is very, very important. We need to